According to the 2020 National Electrical Code, Section 210.11, C4 requires that bathrooms have at least one 20-amp circuit for countertop receptacles. Section 406.4 D1 requires that all 15 and 20-amp receptacles installed in bathrooms be GFCI protected. Section 406.4 D2 allows for GFCI protection to be provided by a GFCI receptacle at the first receptacle outlet of a branch circuit. Based on these code requirements, a local authority having jurisdiction, or OJ, is often correct in requiring a 20-amp GFCI circuit for bathroom receptacles. It's important to understand the specific requirements to ensure compliance and safety in your electrical installations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical wiring and equipment to minimize hazards. In the context of bathroom receptacles, several key sections of the NEC are relevant. Firstly, Section 210.11. C4 mandates that bathrooms must have at least one dedicated 20-amp circuit serving the countertop receptacles. This requirement aims to accommodate the simultaneous use of multiple appliances such as hair dryers and curling irons, without overloading the circuit. Secondly, Section 406.4. D1 stipulates that all 15 and 20-amp receptacles installed in bathrooms must be ground fault circuit interrupter, or GFCI, protected. GFCI protection is crucial in bathrooms due to the increased risk of electric shock in wet environments. A GFCI device monitors the current flowing through a circuit and quickly cuts off power if it detects a leakage current, preventing potentially fatal shocks. Thirdly, Section 406.4. D2 provides an alternative method for providing GFCI protection. Instead of using GFCI receptacles throughout the bathroom, you can install a single GFCI receptacle as the first outlet on a branch circuit. This GFCI receptacle will protect all downstream receptacles on the same circuit. Therefore, understanding these code requirements is essential for electrical contractors and homeowners to ensure compliance and safety in bathroom electrical installations. Failure to comply with these regulations can result in inspection failures and, more importantly, increase the risk of electrical hazards. Now, let's explore some common scenarios and solutions related to bathroom receptacle installations. Suppose you have an existing bathroom with a 15-amp circuit serving the receptacles. To comply with the NEC, you would need to upgrade the circuit to a 20-amp circuit using 12 American wire gauge (AUG) wire and install GFCI protection. This may involve replacing the circuit breaker in the electrical panel and running new wiring to the bathroom receptacles. Alternatively, if you prefer to avoid rewiring the entire circuit, you can install a GFCI receptacle as the first outlet on the existing 15-amp circuit. This will provide GFCI protection for all downstream receptacles, but it's important to note that the circuit will still be limited to 15 amps. Another consideration is the location of bathroom receptacles. The NEC requires that bathroom receptacles be located on the bathroom wall, not in adjacent rooms such as walk-in closets. This ensures that receptacles are readily accessible within the bathroom for convenient use of appliances. When installing GFCI receptacles, it's crucial to follow the manufacturer's instructions and test the device to ensure proper operation. GFCI receptacles typically have a test button that should be pressed monthly to verify that the device is functioning correctly. If the GFCI receptacle fails to trip when tested, it should be replaced immediately. In addition to GFCI protection, it's also important to ensure that bathroom receptacles are properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. Receptacles should be connected to a grounding wire or grounded metal box to ensure proper grounding. Furthermore, it's essential to use appropriate wiring methods and materials for bathroom electrical installations. Wires should be properly sized for the circuit amperage and protected from physical damage. Electrical boxes should be securely mounted and made of non-conductive materials. It's also important to avoid running wires through wet locations or areas where they could be exposed to moisture. When working with electrical wiring, always disconnect the power at the circuit breaker before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. In conclusion, understanding and complying with the NEC requirements for bathroom receptacles is crucial for ensuring safety and preventing electrical hazards. By following the code guidelines and using appropriate wiring methods and materials, you can create a safe and functional bathroom electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about electrical installations. Let's delve a little deeper into the specifics of GFCI protection. A GFCI device works by monitoring the balance of current flowing through the hot and neutral wires in a circuit. Under normal conditions, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, if there is a ground fault, such as when current leaks to ground through a person's body, the current balance is disrupted. The GFCI device detects this imbalance and quickly trips the circuit, cutting off power and preventing electrical shock. GFCI receptacles are typically installed in locations where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor areas. In bathrooms, GFCI protection is required for all 15 and 20 amp receptacles, as well as for other electrical equipment such as lighting fixtures and exhaust fans. There are two main types of GFCI devices: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are installed in place of standard receptacles and provide GFCI protection at the point of use. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. When choosing between GFCI receptacles and GFCI circuit breakers, consider the specific needs of your installation. GFCI receptacles are typically more convenient for providing GFCI protection at individual locations, while GFCI circuit breakers are more suitable for protecting entire circuits. It's also important to note that GFCI devices have a limited lifespan and may need to be replaced periodically. Over time, the internal components of a GFCI device can degrade, reducing its ability to detect ground faults. It's recommended to test GFCI devices monthly and replace them if they fail to trip when tested. In addition to GFCI protection, it's also important to consider arc fault circuit interrupter or FSI protection. FSIs are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. FSIs detect these arcing faults and quickly trip the circuit, preventing electrical fires. The NEC requires FSI protection for most branch circuits and dwelling units, including those serving bedrooms, living rooms, and hallways. While FSI protection is not specifically required for bathroom receptacles, it's a good idea to consider adding FSI protection to bathroom circuits for added safety. FSIs are available as both circuit breakers and receptacles, similar to GFCIs. When installing FSIs, it's important to follow the manufacturer's instructions and test the device to ensure proper operation. FSIs can be sensitive to nuisance tripping, so it's important to choose FSIs that are designed for the specific type of circuit being protected. Furthermore, it's essential to use appropriate wiring methods and materials for all electrical installations. Wires should be properly sized for the circuit amperage and protected from physical damage. Electrical boxes should be securely mounted and made of non-conductive materials. It's also important to avoid running wires through wet locations or areas where they could be exposed to moisture. When working with electrical wiring, always disconnect the power at the circuit breaker before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. In conclusion, understanding and complying with the NEC requirements for bathroom receptacles, GFCI protection, and FSI protection is crucial for ensuring safety and preventing electrical hazards. By following the code guidelines and using appropriate wiring methods and materials, you can create a safe and functional bathroom electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about electrical installations. 1. Understanding the purpose of a rough inspection is important. 2. Rough inspections are typically performed after the electrical wiring, plumbing, and framing are complete, but before the walls are covered with drywall or other finishes. 3. The purpose of a rough inspection is to ensure that the electrical, plumbing, and framing systems are installed correctly and comply with the applicable codes and regulations. 4. The inspector will typically check the wiring, conduit, and boxes to ensure that they are properly sized and installed. 5. They will also check the grounding and bonding systems to ensure that they are properly connected. 6. In addition, the inspector will verify that the electrical system is protected by overcurrent devices, such as circuit breakers and fuses. 7. If the rough inspection fails, you will need to correct the deficiencies and schedule a re-inspection. 8. It's important to address any issues identified during the rough inspection promptly to avoid delays in the construction process. Remember that local AHA can sometimes have differing interpretations or additional requirements beyond the NEC, so it is best to clarify any specific concerns with them directly. Also, keep in mind that while moving a receptacle to an adjacent room may seem like a simple workaround, it is generally not compliant with the NEC because receptacles are intended to serve the specific room in which they are installed. Finally, always prioritize safety and compliance when working with electricity. If you're unsure about any aspect of the electrical installation, consult with a qualified electrician. The advice provided here is for informational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician for any electrical work to ensure compliance with local codes and safety regulations.